Hello everyone, Heather Heward here, Senior Instructor at the University of Idaho and avid fuels sampler. Let's first establish that knowing fuel loading is important for fire and fuels management. Good. Now that that's settled, what is the most accurate way to know fuel loading? Well, pick it up and weigh it, of course. But that would be a huge time suck and not to mention awful for the environment. So what do we do instead? We sample. There are lots of methods for sampling fuel loading. One of the methods that has a long history in fuels management is the planar intercept method, meaning make a plane or line and observe what intersects that line. The specific planar intercept method that is used for fuel loading sampling is the Brown's transect. This video is going to give a broad brush overview to what the Brown's transect is and some of the rules of the game, but it's not intended to be a comprehensive training. You can see the 1974 publication, Handbook for Inventorying Downed Woody Material, for the whole story. Let's tune into a fire effects crew from Yosemite performing a Brown's transect. They're just going to click along doing their work just to be a demonstration on what the process looks like in all of its glory. So how do you begin any sampling adventure? With the establishment of the sampling design and protocols, or rules. These protocols are based on what you want to know about your site. What you want to know is based on your objectives. This video is not going to go into details about how sampling designs are created, but I would like to put a plug in for how important it is to understand your sampling design and ideally how to make one to measure different objectives. If you are considering using Browns, then you are probably interested in fuel loading or perhaps presence of certain classes of fuels. So let's say you want to know the fuel loading on a site before a prescribed burn so that you can model fire behavior, effects, and smoke. And also so that you can sample fuel loading after the burn to see if you have or have not met your objectives. After you establish what you are going to sample, you need to know what tool you will use, in this case, a Brown's transect, and the protocols for that tool. So let's get into it. To start off with Browns, you first establish your plot center, or some determined starting place in your plot. You record site and location information for that spot, and maybe even put in a permanent marker, because as much as you'd like to think that you'll be able to remember where that spot is, chances are that even if you go there before it burns, you're not going to be able to remember one plot from the other. So mark your location. Now we stretch out the tape from that plot center and start to gather information. You usually have one counter and one recorder. The counter is going to count or measure fuel components at various places along the transect. Where they measure what depends on the sampling protocols. I will give you some protocols for the sake of discussion, but it's important to note that these are not hard and fast breakpoints for what you'll need to measure. As with anything in sampling, the most important rule is that you record what you sampled so that it can be replicated. If you sample 1 hour fuels for 10 feet and the next person samples for 6 feet, those two numbers will be incomparable without knowing the distance that each of you sampled. Okay, so our protocols will state that we sample 1 and 10 hour fuels in the first 6 feet. If you don't know what 1 and 10 hour fuels are, pause this and go and watch Introduction to Fuel Loading, linked to in the description. The counter will need a go, no-go gauge, which can be anything that has 1 1/4-inch notch, 1 1-inch notch, and one side that's 3 inches. It's an added bonus if you have a ruler on one side for measuring Duff and Litter depth. A hotel key card works great. I don't recommend an old credit card. That could lose you some money. So the counter goes along and tells the recorder how many 1 and 10 hour fuels are in that 6-foot section. Ready to hear some of the rules of this game? Well, first off, you are only measuring things that are dead, downed, and woody. Still alive but downed? Nope. Dead but suspended more than at a 45-degree angle? Nope. Herbaceous? Nope. Next rule. You are only measuring 1 and 10s that are below 6 feet. This is surface fuel loading, and above 6 feet are aerial fuels. What about those sticks that are covered by litter? Well, if they're covered by litter, they will burn like litter. Therefore, they are litter, and not 1 and 10 hour fuels. And what if there are sticks that cross the plane at one point and then bend and cross it again? Well, they get counted both times they cross. Okay, now our 1 and 10s are counted. On to the 100 hour fuels. We will count these out to 10 feet along the line. Why does that get more length? because there are usually less of them. And in order to capture any, we need to have a longer line. For the 1,000 hours, we will sample those until the end of our transect, or let's say 50 feet in this case. Ready for some more rules? What if the log is partially buried? Well, is the center axis above or below the duff? If the center axis of the log is below the duff, then it gets counted as duff. If it's above, it gets counted as a log. If it's counted as a log, the protocol dictates that you give it a number and record its diameter. And what if that log is not in the shape it once was in its early days of being a dead tree? Well, you do a little mind game and form that log into the shape it might have been and record that. Okay, at this point you might be thinking, what kind of hocus pocus science is this? Well, folks, this, as you can tell, is not an exact science. We are just going for general estimates of loading with the main intent of making these measurements repeatable, which is already hard enough with the rotating door of seasonal workers that are often taking these measurements. So, what about Duff and Litter? You might have noticed in the video that they're measuring Duff and Litter every 5 feet or so. They must have an objective to really understand Duff and Litter cover. To measure Duff and Litter, you take a trowel or the heel of your boot and try to get a flat-faced hole in the ground. Measure the depth of each and cover it back up. What if your established measurement spot has a log or a rock there? Well, choose a nearby location on or off the transect, record the offset, and measure the Duff and Litter depth there. Great. You've collected the information for your Brown's transect. Now, how many more transects do you have to do? Here's where I do have some bad news for you. It turns out natural fuel beds, as opposed to slash or activity fuel beds, are really variable. That means you are pretty unlikely to capture the variability that exists in your area, with only a couple of transects. In fact, work by Bob Keane and others showed that in order to capture the variability in an acre, you would need something like 100 transects. But let's be real, no one is going to do that many samples. So is it even worth sampling with Browns? Yeah, there's still value in these numbers, even if you're not getting anywhere close to the number of transects needed to truly capture variability. Some sampling is always better than none. Sampling of any kind is especially valuable if you're going back and sampling the same places over and over, looking for changes over time. There's also a question with Browns of how you actually get the fuel loading. You have a bunch of tallies at this point, but no loading numbers. You'll need to enter your measurements into a system like FFI, or Feet and Firemon Integrated, which will produce a loading output that you'll need. This system is a useful tool for containing your longitudinal, or over time, sampling information. If getting more accurate fuel loading measurements in less time and without having to enter numbers into a system to get loading is important to you, I would recommend exploring the photo load sampling method. As with anything in this business though, having more than one tool in your tool belt is important, and now you at least have a concept for what the Brown's Transect tool is. Happy sampling!
Litter is 0.4. 68.1. I'll do DH first. Okay. Duff is 0.8.